Good morning, students. Welcome back. So last time we have studied about the formula of trapezium. Now try these. Today we are going to try these on page number 172. First one from that. Nazma's sister also has a trapezium shaped plot. Divided it into three parts as shown in the figure. So you can see here, this is the trapezium plot W, X, Y, Z, and it has been divided into three parts. This is a right angle triangle, this is a rectangle, and again this is a right angle triangle. Okay. Show that the area of the trapezium WXYZ is equivalent to H into bracket A plus B upon 2. Okay. Now, see here. This is right angle triangle. The base of that length is C and height here is H. Okay. Again, this is a rectangle. So the length of the rectangle is B and breadth is H. Again, this is a right angle triangle. The base of that right angle triangle, the length of it is D and its height is H. Now, the total length of this base of the trapezium, that is WX, is equivalent to C plus B plus D, that is total A. Okay. Now, we are supposed to show that area of trapezium WXYZ is equivalent to H into bracket A plus B upon 2. Okay. So, let us do that. So, first we will find out area of this trapezium. Okay. Now, here we will name these parts. Okay. So, I'll name this as A, capital A, and this as capital B. So what happens? It becomes easy for naming the figures. So first we will find out area of triangle WAZ. Now we know the formula for area of triangle, right angle triangle. Yes, half base into height. So half base into height. Purposely I am not using the symbols because we already have B and H. Okay, so I am not using the shortcuts B and H. Okay, now here what is the base? Half into C, and what is the height? H. So I get half CH. Okay, then we'll find out area of a rectangle. Area of a rectangle ABYZ. Now that is equal to length into breadth. Am I right? Okay. Now here, what is the length? Length is B. And what is the breadth? Breadth is H. So that is BH. Okay. And then area of triangle. Again, it is a right angle triangle. Area of triangle YBX. Okay. So again, half base into height. Right? Now, here, what is the base? Base is D. And what is the height? Height is H. Okay. Now, so here what we are going to do, this total area is equivalent to area of this trapezium. Okay. So area of trapezium. Area of trapezium WXYZ, that is equivalent to area of triangle WAZ plus area of rectangle ABYZ and plus area of triangle YBX. Right? Okay. Now, what is area of triangle WAZ? That is half CH plus area of triangle, quadrilateral ABYZ BH plus and area of triangle YBX, it is half DH. Right? Now what is common here? Common is H. Okay. So what you will do, take out common h. Left is c upon 2 plus b plus d upon 2. Now denominators are not same, so you need to equalize them. So multiply and divide by 2. Okay, so I will have h c upon 2 plus 2b upon 2 plus d upon 2. Now see, denominators are same. I hope you understand. Right? Now the denominator is same. So now how I can write? That is equal to h into bracket c plus 2b plus d whole divided by 2. Okay. Now this 2b, I will write it as b plus b. Is there any change? No, not at all. Right. So c plus b plus b plus d upon 2. Okay. Now what I am doing, see here, wx is equivalent to c plus b plus d. So I will bring this together. So see here, h into c plus b plus d plus b upon 2. Just I have got this b here and I have got this d here. Okay. I have just changed their places. Now c plus b plus d is nothing but small a. Right. So that is equal to h into bracket a plus b upon 2. Now what is a? That is the base of the trapezium. What is b? That is length zy. Now these are what? Two parallel sides. Now see whether you have got this, what we were supposed to show. Yes. Therefore area of trapezium wxyz is equivalent to h into bracket a plus b upon 2. H into a plus b upon 2. In other words, sum of the parallel side, half into sum of the parallel sides multiplied by h. Hence the proof. Now second example from this, you have to substitute the values. Okay, that is, you have to take h is equal to 10, c is equal to 6 and b is equal to 12 and d is equal to 4. And then you have to substitute them in this expression. Okay, and you have to find what is the answer. So second one, you will do it as homework. Okay, now let's move to the next part. Now there is again one more activity, that is do this, that what we are going to do. Okay. Now in that do this, what we are supposed to do, we are supposed to draw a trapezium like this. Okay. Here also I have drawn trapezium wxyz. Okay. Whose length at the base is a and this length is b and its height is h. Then what I have done, I have determined the midpoint of this side, that is xy. Okay. I have found out the midpoint of xy and I have named it as a. Then I have joined that a to z. I have joined this point a to z here. Okay. Now you get a triangle. Now what you are supposed to do, you are supposed to cut this triangle. Okay. And then try to connect it here. See what you get. Now by this activity, what we are going to do, we are going to verify the formula that we have got. That is, area of trapezium is equivalent to half into sum of the parallel sides multiplied by height. Okay, this is the verification for that. So what we will do, we will cut here now. Okay, so I will cut this trapezium, right? So you can see now I have cut this trapezium along this segment AX. Okay, so AZ. Okay, and this is the triangle I have got. Now you can see here, this is point A here. Okay, this is Y and here it is Z and this is the length B. Okay, now what I have done, I have got a similar trapezium pasted on a paper. So I am going to paste this triangle here like this. See here. Okay. Can you see? Okay. And see then which figure you get. Okay. So I will paste it here. Right. So now see here. I have pasted this cut part here. Now to understand what figure we have got, I am just holding a white piece of paper over the part here and see what you get. What is this figure? Oh yes, it is a triangle. Now what type of triangle it is? It is a, you can see here, this is the height. Okay, this height is h. Okay, and this is the base, right? This is the triangle. Now this length is a and b. So total length a plus b. Okay. Now area of triangle. What is area of triangle? So area of triangle, you get it as, now this triangle will be triangle WBZ. Okay. So that is the triangle which is formed now. So triangle, this triangle will be formed. See here, WZ. Okay, so this is WBZ. So we'll name it as WBZ. It is given in the book. Okay, so half into base into height. Now, so what is the base here? This is A till here. Okay, and this is B. So A plus B. So half into A plus B. And what is the height? Now, this is the height. Okay, this is the height. And what it is? H. So, is it verified? Yes, it is. A plus B upon 2 into H. That is sum of the parallel sides. Now, this was one of the parallel sides. Here it was present. Okay, it was present here. We have cut it and we have got it here. Okay, and so we got the figure, new figure as triangle, right? And so these two are parallel sides. Okay, so sum of the parallel sides multiplied by h. So formula of trapezium is verified here. Now we are going to solve, try these examples. I will solve one of them, second one, or first one you will solve is at homework. I am going to solve second one. Try these, page number 173. Find the area of the following trapeziums, figure 11.8 from that second one. So you can see this is given 10 centimeter, this is height is 6 centimeter and this parallel side second is 5 centimeter. So here we can say it like this. Here A is equal to 10 centimeter, you can assume, okay. B is equal to 5 centimeters and H is equal to 6 centimeters. That becomes easy, okay. So area of trapezium. What is the formula? H into A plus B upon 2. Okay, what is H? 6 into A 10 plus B 5 upon 2. Okay, so that is equal to 6, 10 plus 5, 15. 15 upon 2. So 2 1s are 2, 2 3s are 6 and 15 3s are 45 square centimeters. Right? So therefore, area of trapezium is, area of trapezium is 45 centimeter square. Okay? So first example, you will solve it as homework. Now, again, on page number 173, we will go for do this. Now see, do this on page number 173. In class 7th, we learned to draw parallelograms of equal areas with different perimeters. Can it be done for trapezium? Check if the following trapeziums are of equal areas but have different perimeters. Figure 11.8. 9. Now I have drawn them here on the board. Actually they are on the graph paper. You have to check it. Okay. Now, so these are two parallel sides. This is the height. So first we will find out the areas of the trapezium. Okay. So area of this, that is equal to h into a plus b upon 2. Now here h is 4. A is suppose 10. B is 14 upon 2. Okay, so 4 into 10 plus 14, 24 upon 2. Okay, so 2 ones are 2 twos are 4 and 24 twos are 48. Okay, 48 square units. We don't know the unit what it is. Right? Now, we will find the perimeter of it also. So, perimeter. Now, perimeter here is sum of all sides. Right? So, that is equal to 5 plus 10 plus 4 plus 14. Sum of all sides. 5 plus 10 plus 4 plus 14. Now 5 plus 10, 15 plus 4, 19. 19 plus 10, 29. 29 plus 4, 33. Okay, 33 units. We don't know the unit. Now, for this area, again, h into a plus b by 2. Now, I am not using the formula. What is h here? 8 into a. Suppose this is 8 and these are the two parallel sides. So, 8 plus 4 upon 2. Right? Now, 8 into 8 plus 4, 12. 12 upon 2. 2 ones are 2 six are. And 8 six are 48. So, 48 square units. Are they equivalent? Yes, they are. Okay. Now, perimeter. So, let us find out the perimeter what we get. Now, again, perimeter is sum of all sides. So, 8 plus 4 plus 8 plus 8. So, 8 plus 4 plus 8 plus 8. Now, 8 is a 24 plus 4. 28. Right? Oh, 8 plus 4, 12 plus 8. 20 plus 8, 28. So, 28 units. Now, for this, see here. What is the area? Now, which are the two parallel sides? These are the two parallel sides. Find out the first parallel side. Now, which is the height here? Now, this is the height. This side itself is the height. Okay. So, h, that is 6 into a plus b. So, 6 plus 10 upon 2. So, 6 into 6 plus 10, 16. 16 upon 2. 2 ones are 2 eights are. And 8 six are 48 square units. Right? And perimeter. Now, what is the perimeter? Sum of all sides. So, 6 plus 6 plus 10 plus 7. So, 6 plus 6 plus 10 plus 7. So, 6 plus 6, 12. 12 plus 10, 22. 22 plus 7, 29. Now, you can see here, all these three figures, they have got same area, 48, 48, 48. But the perimeter is different. Here it is 33, here it is 28, here it is 29. Okay, and keep this in mind. Congruent figures, they always have got equal areas. But the reverse is not true. The converse is not true. Means what? The figures which have got equal areas, they need not be congruent. They are not always congruent. Or, in other words, they may or may not be congruent. Now here, these are not congruent. These trapeziums, they are not at all congruent. Okay. They have got equal areas, but they are not congruent. Congruent figures, they always have equal areas. But two figures having equal areas may or may not be congruent. So this is the example here. Okay. Now let's move further. Now next part is to derive the formula for area of a general quadrilateral. Whatever may be the quadrilateral given. So we can use that formula. That is the general formula. Okay. Now here, this is any quadrilateral which is given. So we want to find the area of it. So we find it out by triangulation method. What is triangulation method? To divide that given quadrilateral in triangles. So what we have done here, we have drawn one diagonal AC. So what we got? We got two triangles, triangle ABC and triangle ADC. And we know the area of formula to find out area of triangle. What it is? Half base into height. So I can use that. Now here, triangle ABC, height of triangle ABC is H1 and height of triangle ADC is H2. So let us find out. Okay. Now see, area of triangle ABC here is half into base into height. This is the general formula for triangles, right? Now, so half, what is the base here? AC, length AC. Okay, so AC into height is H1. Okay, now area of triangle ADC, again half into base into height, right? Okay, so half, what is the base here? Again AC. AC is the base. This is the height. Okay, and height is H2. Now total area of the quadrilateral. So area of quadrilateral A, B, C, D. So what we have done? We have determined in the form of areas of triangles. So area of triangle ABC plus area of triangle ADC. Now what is area of triangle ABC? Half into AC into H1 plus area of triangle ADC, half into AC into H2. What is common? Half and AC. Take it out common. So half into AC into H1 plus H2. That's what it is left. Now, what is AC? AC is nothing but the diagonal. We'll represent it as D. Okay, so you get half into D into H1 plus H2. So this is the generalized formula for any quadrilateral. So therefore, area of quadrilateral is equivalent to half into D into H1 plus H2. Now what is D here? Length of the diagonal. D for diagonal. Okay, H1 and H2. These are the two heights on the diagonals. Okay, so this is the general formula for general quadrilateral. Okay, so suppose if this length is given, length of the diagonal, if D is equal to 10, okay, H1 is equal to 5 and H2 is equal to 8. So find the area of the quadrilateral. So substitute here in this formula. So area of quadrilateral. So area of quadrilateral is equal to half into D into H1 plus H2. So that is equal to half into 10 into 5 plus 8. Okay, so 2 ones are 2 5s are. So 5 into 8 plus 5, 13, and 13 5s are 65. So that is the area of the quadrilateral. Do you understand? Okay, now let's move to try these. Now see this, try these. We know that parallelogram is also a quadrilateral. Yes, definitely. Let us also split such a quadrilateral into two triangles. Triangulation method. Find the areas and hence that of the parallelogram. Does this agree with the formula? Do you know already? Okay. Now, so we are trying to verify the formula of parallelogram. I know you have studied it. You know very well. Just with the help of triangulation method, we are trying to verify it. Now, here I have drawn the parallelogram. This is the length of the side B, and this is opposite side. So they are congruent. So this is also B. Now this is the height H. This is also height. Now height, it is also going to be congruent. Now we have drawn one diagonal. Okay. Do you understand? Now this is the diagonal So we are divided into two triangles. So suppose if I name the figure, it will be easy for us, right? Now, so suppose the name of this figure is PQRS. So I get two triangles, triangle PQR and triangle PSR. Okay, so area of triangle PQR, what it is? Yes, half into base into height. Right? Now, what is the base here? QR. See, where is the perpendicular? On which side it is. So that becomes the base. So this becomes the base. So base is B. Length of that is B. And height is H. Okay. So you get half into B into H. That is what you get. That is area of triangle PQR. Now, area of triangle PSR. What it is? Again, half into base into height. So, half. Now, for this triangle, what is the base? See, where is the height? This height is on this base. So, PS is the base. So, that is B. Into height is again H. So, again you get half into B into H. Okay. Now, area of parallelogram, we will find it out. So, area of parallelogram PQRS, that is equal to area of triangle PQR plus area of triangle PSR. Okay. Now, what is area of triangle PQR? Half into B into H plus area of triangle PSR, half into B into H. Now, everything is same. So, half BH plus half BH. How much it is? Say 1 upon 2 plus 1 upon 2. It becomes 2 upon 2. So, 2 upon 2 BH. Okay. Now, so 2 gets cancelled. So, what it is? B into H. That is what? Base into height. So, area of parallelogram is equivalent to base into height. What formula you have studied? Does it match here? Oh yes, exactly, it matches here. Okay, so we can verify it by triangulation method. So the final question, do these agree with the formula that you know already? Yes, it agrees. Yes, it agrees with the formula we already know. Okay, so dear students, let us stop here today. Okay, so first I will write your homework on the board, right? So your homework page number 172, try these, question number 2. Try these, page 172, question 2. Again, try these, page 173, question 1. Okay. That is your homework. Okay. So this is the homework to be done. It's not more homework. I know you are going with your tests. So only 2 examples I have given. So let us stop here today. I believe you will write all this in your notebook and do that activity. Try to verify it of yourself. Okay. And so let us stop here today and we'll meet in our next period. Till then, goodbye. Have a nice day. Thank you.